Hi everyone, thank you for having me. Today I'm going to show you how to build a SharePoint agent that actually remembers, not just within a single conversation, but across sessions. We will do that by combining two features in Foundry Agent Service, Azure Foundry Memory and SharePoint grounding, all built in .NET. Uh, okay, quick intro. Before we get started, my name is Ramin Ahmadi. I'm a developer architect at Advania, based in London. I write about Azure AI and Microsoft 365 development at codingwithramin.com. And all the code you will see today is up on GitHub. So feel free to grab the repo after the session. And if you want to connect or follow along with future work, you're very welcome to. Here's the plan for this session. We will start by grounding the problem, why stateless agents are frustrating in real-world scenarios. Then I will walk you through how Foundry Agent Memory actually works under the hood, so you understand what's happening before we look at any code. After that, we will cover what you need to set up in Azure before writing a single line of code, like projects, models, connections, and permissions. Once that's in place, we will jump into Visual Studio and walk through the actual implementation. And finally, we will close with live demo and the practical limitations you should be aware of before using this in production. Okay, let's start with something most of us have hit in production. You built an agent. A user comes in the morning and let's say says, I'm in compliance team, I work on data privacy, and I want bullet point summaries of third-party data sharing policy. The agent responds well. They come back maybe after lunch or the next day or maybe next week, start a new session, and it's completely forgotten, all of that. They have to start over every single time. So developers have tried three main workarounds for this. The first is just injecting the entire conversation history into the prompt. That works for a bit, but is completely unselective. Every turn goes in, your token usage balloons and performance drops as the conversation grows. Another approach is to build a custom vector store. You embedded important facts, push them into something like AI search or vector database, and retrieve them when needed. That gives you semantic search, which is powerful, but now you own everything around it, deciding what to extract, managing embeddings, maintaining the index, and figuring out what happens when information changes or conflicts. The third option is keeping a state in a traditional database. You store structured preferences or settings and inject them at prompt time. It's simple and reliable, but it breaks down quickly once you deal with unstructured or evolving context. And the real issue with all three is the same. You end up spending huge amounts of time building and maintaining memory infrastructure instead of focusing on the actual behavior and value of your agent. That's exactly the Foundry agent memory is designed to solve. So what does Foundry agent memory actually do for you? At a high level, it owns the entire memory pipeline end to end, and it does that in four phases. First, extraction. As the user interacts with the agent, the system automatically identifies the bit of information that are actually worth keeping. Things like preferences, roles, recurring topics, and important contexts. You don't have to decide that upfront or hand roll logic to capture it. Next comes consolidation, and this is the really important part. An LLM continuously merges and deduplicates what is learned. And if a user said last month they prefer like dark roast coffee, and today they say they've switched to light roast, the system resolves that change. It doesn't just stack both values and leave you to figure out later. Then there's retrieval at the start of each conversation, and again on every turn, the system uses hybrid search to pull back only what's relevant right now. So memory stays contextual, not bloated. And finally, customization. You get control over what the system should even pay attention to. That happens through the user profile details parameter. For example, for a SharePoint document agent, I might say track the user's role, department, frequently accessed topics, and document preferences. Or for a travel agent, it's things like airline preference or dietary requirements. That way, the system captures signal, not noise. There are also two distinct memory types. User profile memory stores relatively static facts, who this person is, and that's retrieved at the start of every session, regardless of what the conversation is about. Chat summary memory, on the other hand, captures what was discussed previously. That's contextual and only brought in when it relevant to the current turn. And finally, this matters from a security and multi-tenant point of view. Everything is scoped per user. So each user gets a fully isolated memory partition. In my case, I derived that scope from the intra-tenant ID and object ID in the JW token. That guarantees memory is never built across users ever. Okay, let's zoom out and look at the overall flow. Everything starts with the user talking to the SharePoint memory agent. This is just a .NET Console app, so nothing fancy, but it's the point where all these pieces come together. Under the hood, the agent has two tools registered. The first one is memory tool. This is what talks to the Foundry memory store. It runs automatically at the start of session to pull in relevant memory, and again after each turn to keep things up to date. You don't call it manually. The orchestration handles that for you. The second tool is SharePoint grounding tool. This connects to your SharePoint tenant via the connections API and does permission ever search. So the agent only ever sees documents the user is actually allowed to see. Each of these tools routes to its own backend. Memory goes to the Foundry memory store, and SharePoint queries flow through the Microsoft 365 Copilot Retrieval API into SharePoint Online. What's nice is that all of this is just configuration. If you look in your app settings.json, that's where everything is wired up. The model names, SharePoint connection name, and the two really important pieces, the user profile details and chat summary details. Those are what tell the memory system exactly what to extract and store. And finally, authentication. Everything uses default Azure credential, locally the Visual Studio or Azure CLI, and in production is managed identity. There are there are no secrets in the code and nothing special you need to swap out when you deploy. Before we touch any code, let's quickly cover what you need to set up in Azure. This is all pretty lightweight if you have used Foundry before. First, you need a Foundry project that gives you a project endpoint URL, and that just drops straight into the app settings.json. Nothing's unusual here. Next, you deploy two models, one chat model and one embedding model. In this demo, I'm using GPT-5 and Chat's embedding tree small for the embeddings. The rules are important here. The chat model is what handles memory extraction and consolidation, deciding what to remember, and the embedding model is purely there to power semantic search when retrieving relevant memories. Step 3 is the SharePoint connection. In connected resources, you add a new SharePoint connection, point it to your site, and give it a friendly name, and that name is the only thing you put in the config. There are no hard-coded connection IDs. The agent resolves the actual ID at runtime using the connections API. And finally, RBAC and licensing. For local development, your identity needs the Azure AI user role, but this one's really important. If users are interacting with the SharePoint grounded agent, they need a Microsoft 365 Copilot license, or you need a pay-as-you-go enabled. That's Microsoft 365 requirement, not a Foundry one, but it does affect whether this works. So you need to budget for it. And that's it. All of this flows into app settings. No secrets, no environment-specific hacks. Same setup locally and in production. Okay, uh, let's go to the demo. Before I show you the code, let's just log into Azure Portal. As I mentioned, you need to set up Azure Foundry project or hub. I just created one beforehand. So this is our Foundry project. So if you go there, this is your project endpoint. You just need to just copy that and put it in your app settings. So as I mentioned again, I'm going to use GPT-4, GPT 5.4 and text embedding 3S for this model. You have to deploy these two models or any preferred models for this. And for the tools, again, you need to create a SharePoint grounding tool. I've created one already. So you just need to give it a name, and this is what you need to put in the app settings. And this is the URL I'm going to use to search documents or data. So this is the SharePoint side. I just put some documents in there so we can use them to search using this tool. And the agent itself, it will be created during running the code, but when it's created, you can see two tools added to this agent. One is the SharePoint grounding and one memory. So this is pretty much the Azure setup and SharePoint that you need to know. If we just switch to the code, so there are a few things here to just talk about. So in the app settings, we need to set up the project endpoint. We have the connection, SharePoint connection name, and also the model's name that we just deployed. And for the memory, there are two important properties that you can see here: user profile details and chat summary details. These are the instructions you give to LLM to let it know what to capture and store. So for example, for the user profile, I just told it to just use user's role, department, document preferences, and some other information from the user, and ignore everything else. And also for the chat summary, you can say what to keep and what to ignore. So this is app settings. In the program, it's really simple setup. It's just getting the values from app settings development.json. Then it builds up the AI project client. For this demo, I'm using Azure AI Projects SDK. And it's just getting the values from app settings and using the default Azure credential and build this AI project client for us. And these are just some commands that I'm going to use, like memories to retrieve the memories or clear the memories, using new to start a fresh conversation or session, and exit to exit the console application. In memory store service, this is where we define the memory. So we take in the AI project client, and then we call this to create the memory store for us. And in the create memory store, first we try to see if the memory exists. If yes, we just take that. Otherwise, using the information like chat model, embedding model description, and profile details, we create that memory. This is also really important. In the options, you can enable or disable those memories. So for this demo, I enabled both profile and chat summary, but you can disable them. In update memories, so each turn is going to update the memory with the summary of the chats from the user message and also the assistant message. And in the search memories, this is something that if you want to retrieve the memories, you can use this function. I will show you when I run this. And in SharePoint Memory Agent, this is just to set up the agent. So in the initialize async, you can see I created an agent with two tools, memory search and SharePoint grounding. These SharePoint connection IDs get resolved by this function, so we can get the connection ID. And if we can resolve that, it just fall back to the memory tool only. There are a couple of other functions here, but because of the time, I'm gonna just skip some of them or just talk through them. So for the start new conversation, it just create a new session. This is for just sending the message to the LLM, and this is for extracting the citations if search is getting some pulling into some documents, and this is to just search for the memories and show them to the user, and this is just for the clearing the memories. Let's run this, and I can just quickly show you what we need to do here. So I've got this running against a real Foundry project with a SharePoint site containing some enterprise policy documents. Let me show you the full flow. First, we need to establish context. So I'm just going to copy this and paste it here. So I'm just telling it who am I and what I prefer. So if I just press enter, it just sends it to the LLM, and also it will try to just store those information in the memory. So we'll keep everything in the memory about the user preferences and also the important information. So now we can ask a SharePoint question. So let's say, what does our data privacy policy say about third-party data sharing? So what it does is going to use the SharePoint grounding agent, and it will search this site collection because we put this URL against that tool, and it will find some information in this document because it's containing that privacy policy information. So as you can see, it just returned the data. So you can see, the section it used for that. And also it just written everything in bullet point because we set that in the preference. So let's do something now. I'm going to just remove this document and upload a new version that was 3.0, and this new document is 3.1, but with some changes in the document. But before we ask anything new, let's just type memories to see what we have stored so far. So it's going to just search memories and return everything. So you can see in the chat summary, it just all the summary of the previous conversations, and also in the user profile is everything about the user, like what user prefers, who the user is, and some other information. So now what we're going to do is just create a new fresh session. So let's say like user come back in few hours or few days, and he wants to get an update about that document. So now we have the new document. It should just automatically retrieve that and get that back to the user. So I'm going to ask, do you have any updates on what we discussed last time? So it's going to pull in those information from the chat summary memory, and also user profiles, and put it in the prompt. As I said, it's contextual, so it depends on what you ask, and if you just fetch those information from the memories to use them for returning the response. So now you should just find this new version of the document, and we will see that it will say some new changes have been identified from that new document. It shouldn't take that long, but it always happens in the demo. So bear with me until I get back to us. Okay, so as you can see, it just immediately found the new document, and you can see it says yes, there's an update in that document, what changed and what didn't change. So it just brings that all for you. Even if you go and just get offline for a few days or a few weeks and get back, it has everything in the memory for you, so you never get lost between your information and sessions. So yeah, that's the demo. Let's go back to the slides so I can show you some other bits about the limitations. Before you ship something like this, there are a few practical limitations you should be aware of. The biggest one is licensing. SharePoint-grounding requires a Microsoft 365 Copilot license on a per-user basis or pay-as-you-go enabled. And as I mentioned, that's a Microsoft 365 constraint, not a Foundry one. On the memory side, there is a limit of around 10,000 memory items per user scope. In practice, that's more than enough, but it's also why those profile and summary details prompts matter. So be selective about what you capture. Also during preview, you're limited to about 1,000 requests per minute. That's fine for development, testing, and maybe pilot scenarios, but it's something to keep in mind if you're load testing. And finally, memory management is scope-based. You can clear a full user scope, but you cannot delete individual memory items yet. So think in terms of user boundaries, not a single fact. Everything we covered today is up on GitHub. There are also 2 blog posts on my blog, codingwithramin.com. Part 1 focuses on memory on its own, and Part 2 walks you through the full experience combining long-term memory and SharePoint grounding. And if you want to go deeper, the Microsoft documents links cover the underlying memory concepts, the how-to guide, and SharePoint tooling. Thank you very much for your time, and I'm happy to take questions.